Gene, we have a situation brewing with the carbon dioxide.
We had a CO2 filter problem on the lunar module,
5 filters on the limb.
which were meant for 2 guys for a day and a half. So I told the doc,
You're already up to 8 on the gauges. Anything over 15 and you get impaired judgment, blackouts, the beginnings of brain asphyxia.
What about the scrubbers on the command module?
They take square cartridges.
The ones on the limb are round.
Tell me this isn't a government operation.
It just isn't a contingency we've remotely looked at.
Those CO2 levels are going to be getting toxic.
Well, I suggest you gentlemen invent a way to put a square peg in a round hole. Rapidly.
Okay, people, listen up. People upstairs handed us this one, and we gotta come through. We gotta find a way to make this fit into the hole for this, using nothing but that.
Transfer learning is something you learn in one situation that affects how you learn or perform in another situation. We need it in our day-to-day lives. Without it, we would have to learn everything over and over again. During this presentation, we will discuss 4 types of transfer learning. Positive transfer, when previous learning facilitates later learning. Negative transfer, when previous learning interferes with later learning.
Don't worry, this time I brought glue. Now let's see. Where's a good spot for it? Right there. That'll be perfect.
Well, what's that you're putting on?
Just some stickum to keep your hair in place.
Something's wrong with your wall. The poster won't stick to it. No wonder. This is hair tonic. That means what you're putting on the mayor's head must be...
Glue. My hands, they're stuck.
Here, Mr. Cavallini. I'll help you.
Ow! What in blazes is going on here?
Now wait, don't touch your hair.
What the... They're stuck!
I tried to warn you.
What in blazes are you doing?
Trying to get my other hand out.
I know something that might work. We learned about it in school. It's called centrifugal force.
Don't you mean centrifugal?
No, we didn't study that yet. Hang on, Mr. Mayor.
What happened?
It worked. Your hands are no longer stuck to your scalp.
Vertical transfer, when the topic builds upon one another. Master of one topic before moving to the next. An example would be mastering addition before moving to multiplication. When knowledge of the first topic is helpful but not essential, this is lateral transfer. Near transfer of skills and knowledge are applied the same way every time the skill and knowledge is used. Far transfer involves skills and knowledge being applied in situations that change. Specific transfer, the original learning task and the transfer task overlap in some way. An example would be knowing about human anatomy would help you as a veterinarian. General transfer, the original task and the transfer task are different in both content and structure.
What are we supposed to be doing? Our teacher said we are supposed to be problem solving.
I read the problem, but she didn't tell us how to do it.
She told us to use critical thinking. I think that means we have to figure it out.
But she didn't tell us the steps. How are we supposed to figure it out without instructions?
Well, Let's try reading the problem to see what we know. Maybe we could start there. I'm going to raise my hand and tell her we don't get it. Then she'll have to give us the steps. She'll just tell us to think critically. That's ridiculous. When are we ever going to have to do that in real life?
The world presents us with many different types of problems, and not all have a straightforward solution. One type of problem is a well-defined problem, and another is an ill-defined problem. In a well-defined problem, the desired outcome is clearly stated, all necessary information is provided, and a particular procedure will lead to a correct answer. On the other hand, ill-defined problems have end results that are not clearly stated. Some important information may be lacking, there is not one particular procedure that will guarantee correct results, and there is more than one possible solution. Well-defined problems, such as the cost of a vacation or the cost of paying off a car, can be solved by algorithms, which are step-by-step procedures on how to solve a problem. Ill-defined problems, such as how to control a junk food habit, how to raise respectful kids, or how different political groups can work together, can be solved by heuristics, which are general problem-solving strategies that may or may not yield a correct solution. Examples of heuristics include talking to yourself, brainstorming, drawing a picture, drawing an analogy, and working backward.
There is a myth that grandmasters can see 10, 15, 20 moves ahead. And it's a great myth because I'm a grandmaster and it makes me look like a super freaking genius. But the truth is, in just the first 4 moves, there are 318 billion ways you could play. Now, that'd be cool if I could pull that off, but grandmasters just can't. It's too much. So we use different techniques to be able to look ahead. And some of these techniques include chunking, which means taking a group of a chess position and seeing what possibilities can come from just that group, or pattern recognition, which is just going over a lot of positions that look very similarly and extrapolating truths from that. The stepping stone method, which is to take a position, freeze it in your mind, and go from there to guess the next position. But one of my favorites that I love to solve these kind of chess puzzles is called retrograde analysis. And what you do with retrograde analysis is that in order to look ahead, it pays to look backward. Here's another puzzle, a little bit more complicated. You have 6 numbers, 1 through 6. The cards are face down. You and I are going to pick a card. You pick a card and you look at it, it says the number 2. I look at my card, I think about it for a minute, and I say, I want to trade. The reason I want to trade, we're going to trade to see who has the highest number at the end. Do you trade with me? Most people say, of course, I got a 2, 2 sucks. They're 4 numbers higher, probability says I'm gonna do better. Wrong answer, you're playing a grandmaster. You start from the back and you work it out. If I had the number 6, would I offer to trade? Of course not, I'm not dumb. What about the number 5? Probably not either, because you're not gonna say yes if you have a 6. Well, if 5's not gonna trade and 6 is not gonna trade, 4 is gonna be like, I'm not trading either because 5 and 6s don't trade. So you see what happens as we work backward. 3 is gonna realize 4, 5, and 6, they don't trade. So the offer is definitely a 1, and all of you who said yes, thanks for your money.
Even though there are different ways to solve a problem, the stages of problem solving are similar. Stage 1 is to understand the problem. Stage 2 is to devise a plan. Stage 3 is to carry out the plan, and Stage 4 is to look backward to evaluate the effectiveness of the plan.
This problem solving, when you embark upon it, you embark upon a goal, you go through a set of steps, and I wanted to talk about my set of steps. So, the first question I ask myself is, what is the problem I'm solving? And while this seems trivial and simple, you have to be super, super clear about this. If you've been given a problem to solve by someone else, and you don't check to make sure you know what that problem you're solving is, you're going to screw it up. But as we go, there is a set of questions which are being asked constantly. Literally every 5 minutes, these questions are being asked. How important is this particular step? How important is it that I get it right? Can I screw it up, or do I only have 1 bar of this special type of unobtainium? Is my machine deteriorating, i.e. me or the tools that I'm using? Is this a step I might be able to improve later so that what I'm building is a stand-in for my solution? Am I missing something stupid? Am I being too clever? Which is another way of saying, am I missing something stupid? Is there a simpler way? Which is another way of saying, am I being stupid? Am I missing something stupid?
Critical thinking is evaluating the accuracy, credibility, and worth of information and lines of reasoning. How can teachers facilitate, transfer, problem solving, and critical thinking in the classroom? Students should learn information thoroughly in a meaningful way, developing conceptual knowledge. Students should learn problem-solving strategies through experience with real-world problems. Students should participate in discovery activities and should have instruction in general problem-solving skills. Students should develop a mental set for transfer and should practice prerequisite skills until they become automatic. Students' early attempts to solve difficult problems should be scaffolded, and problem-solving strategies can be facilitated through cooperative group learning. Classroom assessment practices should include measures of transfer and problem-solving.
Yeah. We got the parachute situation, the heat shield, the angular trajectory, and the typhoon. There's just so many variables. I'm a little
I know what the
lost.
problems are, Henry. This could be the worst disaster NASA's ever experienced.
With all due respect, sir, I believe this is going to be our finest hour.
One minute and 30 seconds to end of blackout.
No re-entering ship has ever taken longer than 3 minutes to emerge from blackout. This is the critical moment. Will the heat shield hold? Will the command module survive the intense heat of re-entry? If it doesn't, there will only be silence.
Okay, flight, that's 3 minutes. We are standing by for acquisition.
Odyssey, Houston, do you read me? Odyssey, this is Houston. Do you read?
The expected time of reacquisition, the time when the astronauts were expected to come out of blackout, has come and gone.
Odyssey, this is Houston. Do you read me? Odyssey, Houston, do you read me?
3 minutes, 30 seconds, standing by.
Odyssey, Houston, do you read me?
That's 4 minutes, standing by.
Odyssey, Houston, do you read?
Hello, Houston. This is Odyssey. It's good to see you again.